I'm Ravi Kambhampati. I'm very excited here to talk about designing resilient and scalable network infrastructure for the digital age. I'm an engineering manager at Realize with strong focus in networking, predominantly in the areas of routing, switching, firewalls, telecommunication. Over the next 30 minutes, we will cover on these following topics related to layer 2 and layer 3 networking technologies, then advanced networking concepts like route distribution, quality of service, and security protocols. Then how automation and AI are shaping the future of networks. And we'll end up with industry applications, key for future trends, and my conclusion on it. So let's dive into the introduction. As we all know, in today's world, network infrastructure is the heart of every digital transformation. It acts as the backbone for seamless data communication, ensuring businesses can operate efficiently in this fast paced environment. The goal of this presentation is take you through critical components of the network design with a focus on how we can make networks both resilient and scalable. These two factors, resilience and scalability, are the crucial because we need networks that not only cover from these issues but also to grow with evolving needs. Next, let's talk about in detail with regards to the switching technologies. At layer 2 of the OSI model, we have the switching technologies. Layer 2 is basically responsible for local transmission within the network segment, and it plays a critical role in how data is handled and moved across devices. One key concept here is the VLANs, or the virtual local area networks. VLANs allow us to virtually segment a network, meaning we can group devices together based on a logic rather than their physical location. Their segmentation enhances the security by isolating sensitive data, improves performance by reducing unnecessary traffic over the network. For example, in the enterprise setting, you could group the accounting department into one VLAN and HR department into another. Even though they may share the same physical network, the VLAN ensures that data is separated. Now we talk about trunking. This is where we allow multiple VLANs to share single physical network link. By doing this, we optimize resources, simplify network architecture. Trunking allows the VLAN to communicate with each other efficiently while maintaining the distant boundaries. And finally, a spanning tree protocol, or STP, is a critical piece of layer 2 technology. It prevents network loops which can be a major issue, especially in large networks where data could potentially circulate endlessly, clogging up the network. STP, or a spanning tree protocol, ensures that there is always a primary path for data and a backup in case the main path fails, adding a much more needed redundancy. Now let's talk about the routing protocols. Now let's shift the gear to layer 3. This is where routing comes into play. While layer 2 focuses on switching within the network, layer 3 enables communication across multiple networks through routing. One of the most well-known protocols here is OSPF, Open Shortest Path First. OSPF is a dynamic routing protocol, meaning it constantly updates itself to find the best path for data transmission. It's highly scalable and it's highly used in large enterprise networks. Then we have the BGP, the Border Gateway Protocol, is essential for managing how packets are routed across the internet. It allows the data to travel between different autonomous systems or networks, especially those controlled by different organizations. Think of BGP as a backbone of the internet. It ensures that data finds its way across diverse networks. Finally, we talk about MPLS, multi-protocol label switching, streamlines the routing process by enabling label rather than long network addresses. This improves speed and efficiency, especially in large networks where there is a lot of traffic. By understanding these layer 3 protocols, we can see how data moves between individual networks and across the broader internet. Now let's talk about the synergy between layer 2 and layer 3. So how do layer 2 and layer 3 work together? The answer lies in their synergy. These two layers are not standalone technologies, rather they complement with each other to create a seamless and efficient network. At layer 2, we use a VLAN for segmentation, creating isolated sections within a network. At layer 3, we use routing protocols like OSPF, BGP to connect these segments, route data between them. This ensures that both isolation and connectivity were key components in modern network design. Let me give you an example. In a corporate environment, you might use a VLAN to isolate the marketing, finance, HR department. However, we still need to communicate with each other at certain points. Layer 3 routing protocols allow this for this communication while maintaining the isolation of each department sensitive data. This integration between layer 2 and layer 3 reduces latency, maximizes throughput, ensures that data moves efficiently across the network without unnecessary delays. It's about achieving the right balance between segmentation and performance. Now, let's talk about the advanced networking concepts. Let's explore some advanced networking concepts. These technologies enhance networking performance, security, and efficiency. First, let's talk about the route distribution. In many large networks, multiple routing protocols are used. Route distribution enables these protocols to coexist by sharing route information across them. This ensures cohesive network operation even when different parts of the network uses different protocols. Then we have quality of service or QoS is basically crucial for prioritizing certain types of traffic over other. For instance, in a video conference, you may need to make sure that video and audio packets are given priority over less critical traffic, like background downloads. By doing this, QoS maintains performance standards even when network is congested. Finally, let's touch down on security concepts like access control lists or ACLs and IPsec. ACLs control who and what kind of certain parts of the network can access certain part of the network. For example, ACLs can be used to ensure that only authorized personnel can access sensitive financial data. IPsec, on the other hand, is a suite of protocols used to secure communication by encrypting and authenticating each IP packet. It's commonly used in VPN to secure remote communications. All of these advanced networking tools play a role in optimizing and securing modern networks. Now, let's discuss security in network design. Security is a critical in every aspect of network design. Without robust measures, even the most efficient network can fall victim to breaches and disruptions. As I mentioned earlier, ACLs or access control lists are used to define which users and systems can access specific parts of a network. ACLs act as a filter based on criteria like IP addresses or protocols. Common use cases is like restricting access to a sensitive data in a corporate environment. For instance, in a financial institutions, ACL might allow only the financial team to access certain database while keeping others departments out. Another key infra security feature is IPsec or Internet Protocol Security. IPsec ensures secure communication by encrypting and authenticating IP packets in a communication session. This is particularly useful in virtual private networks where secure data sends between remote workers and corporate network. With IPsec, you can ensure that the data remains private and unaltered, and even if intercepted by malicious actors. In today's increasingly complex network environments, securing every layer is crucial. Network design needs to account for both internal and external threats, making sure the security is the top priority. Next, let's discuss about the industry applications. So how are these application technologies being applied in real world industries? Let's look into at few case studies that I would like to describe. In a financial operation or an enterprise level operation, network resilience is key for critical business functions. For instance, in financial services, companies rely on high availability networks to ensure uninterrupted operations. By using layer 2 and layer 3 networking concepts, financial firms can create highly resilient networks that minimize downtime and ensure business continuity. In telecom industry, 5G networks are a new frontier. With a high speed and low latency capabilities, telecoms are implementing 5G to provide enhanced service delivery. Here, layer 3 protocols like BGP play a critical role in managing the flow of data across large and distributed networks. Another exciting area is the Internet of Things or IoT. In smart cities, for example, IoT manages the device connectivity and data flow between thousands of sensors and devices. This network needs to be highly scalable and secure to ensure the safety and efficiency of the network city's infrastructure. These examples highlight the real world impact of well designed, resilient, and scalable networks across different industries. Next, let's look into some of the future trends in networking and discuss about some of the automation or recent AI upcoming or developments in networking. So let's start with automation. Automation is quickly becoming essential in network management as network becomes more complex and large. Managing or manually configuring and monitoring a large-scale network is no longer feasible, especially when increasing number of devices and the complexity of the modern networks. Automated tools now handle many routine tasks such as configuration management, network monitoring, and troubleshooting. This reduces the human error and improves overall operational efficiency. For example, rather than having to manually configure every device, an automation tool can basically apply configurations across multiple devices at once, ensuring consistency and saving time. Moreover, automation helps with faster issue resolution when network problem arises. Automated monitoring systems can detect and apply pre-configured fixes without the need for human intervention. Now let's talk about the AI and machine learning and network management. Building on the concept of automation, AI and machine learning are now playing an increasingly critical role in network management. AI and ML have introduced predictive analysis, allowing networks to anticipate issues before they occur. For example, ML algorithms can analyze historical data to identify patterns that might indicate potential network failures, enabling proactive maintenance. Anomaly detection is another key area where AI shines. AI powered systems can continuously monitor traffic, identify unusual behavior that could increase a security breach or a system malfunction. Once detected, these systems can automatically apply corrective measures, minimizing the downtime and reducing the impact of the potential threats. AI and ML are also improving network efficiency through automated decision making by continuously analyzing network performance, and these technologies can significantly adjust configurations to optimize traffic flow, ensuring networks are always running at peak performance. The future of networking will heavily rely on intelligent systems to manage increasingly complexity of the network modern networks. Now let's look into the evolving security trends. As network becomes more distributed and complex, security must also evolve to keep the pace with the new threats. One of the biggest shifts we are seeing in the move from traditional security models to a zero trust architecture. In a zero trust model, we no longer assume that threats are only external. Instead, we treat every part of the network as a potential target. This means every user, device, and data must flow through authentication, authorized, and continuously validated. It is more rigorous approach, but one needs to make sure it's really important or necessary in today's threat landscape. Within this, we are seeing an adoption of more sophisticated and encrypted methods and enhanced identity management systems. Advanced encryption ensures the data is encrypted and it is cannot be read or altered by any means. Meanwhile, the identity solution management ensures that only authorized users have access to sensitive data. Network security is no longer just keeping threats out, it's about protecting the network from both internal and external risk while maintaining performance and resilience. Now that we are at the conclusion and we are trying to wrap up the session, as we wrap up this presentation, let's take a moment to recap the key points. We have explored the foundation of routing and switching, looked at how layer 2 and layer 3 technologies work together to create resilient and scalable networks. We also discussed the advanced networking concepts like route distribution, quality of service, which are critical for optimizing performance in complex environments. Security has been a recurring theme throughout the today's talk, from access control list, IPsec to evolving landscape of zero trust architecture. As network continues to grow in complexity, security must remain a top priority. We have also touched on importance of automation, AI, machine learning in shaping the future of network management. These technology are not just in the future; they are already transforming how we design, build, and manage today's network. Finally, we looked into the real world application of these technologies in industries like financial services, telecom, IoT, and discuss some of the trends that will continue to prevail to shape the future of networking. As we move forward, the key takeaway is that the resilient and scalable and secure networks are foundation of any successful digital transformation. The decisions we make today in designing these networks will shape how businesses will operate together. Thank you for all for your time and attention. I hope this talk provided you with some valuable insights and into the future of networking infrastructure. I am always happy to take any questions that you might have.